Okay guys, we're going to focus a little bit more on the fundamental theorem of algebra and more in depth on how to work with polynomial functions. If I were to tell you to find all the zeros of this function here, according to the steps that we've taken, the first thing you should do is find your rational zeros by taking the factors of 6 and dividing them by the factors of 1 here, but you want the positive and negative versions of that. Then you would take that and do synthetic division. And so putting a 0 in for the cubed function there, for the cubed term actually, you'll find out that 1 is a factor. Alright? Which means that this goes down to a degree of 4. But I need to keep going, and so using finding numbers to put in, I find out that -2 would be another 0, because I get 0 once I substitute -2 in. Okay? And so here's the idea. If I were to use my graphing calculator, and I told you guys about this, it makes it a little bit easier because I can see where it touches or crosses the x-axis. And so I know I could use 1 here and I could use -2. And so that's why I use -2 here. I knew I couldn't factor this, and so I went and did synthetic division again, and I get this. Of course it is a factor, but I get this as a polynomial. Again, this does not factor by grouping or anything, and so I do synthetic division again, and I find out that 1 works again. So 1 actually works twice. Sometimes this is possible that you do reuse a 0. And so I find out that 1 works again, and once I use that to get another 0, I get this quadratic polynomial, which doesn't factor. And so when I do the quadratic formula with this, I'm just kind of learning to do this, so if I'm going fast, you need to pause or rewind. I went through this whole problem, and I found out that x equaled 1 plus I squared of 2 and 1 minus I squared of 2. Alright? And so my solutions were 1, -2, 1 again, and those two. There's this thing called factored form or factored theorem, which says that you can write them. Now that factored theorem says that you can write your answers all as factors. And in order to do that, you need to remember this. Any of your zeros, any of your solutions goes in this blank. That box is not really there. It's just like a blank. If you ever want to write your answers as factors, just put them in this, no matter what they are. So for example, if I put 1 into that, I would have x minus 1. If I put -2 into that, I would have x plus 2, because minus a negative becomes a positive. Then I would have x minus 1 again with that. Now here's where it gets a little weird, because this whole thing is a 0. So it will be x minus, in parentheses, 1 plus I radical 2. And then x minus, in parentheses, 1 minus I radical 2. And so both of those went into that blank, and that's where you got those. And so this is the factored form of my function, my original function at the beginning, which was this here. In factored form, looks like this. This is basically all the zeros that we have. I could take each one of these and set them equal to 0 and get that back. And that's the idea. Alright? Now what you'll notice here is that I rearranged this or rewrote this, and I just put x minus 1 together. I don't have to have two separate ones. Notice that the exponent here is 2, and the exponent in each one of these other places is 1. And by the way, I use brackets because you don't ever want double parentheses. It looks confusing, but it still means multiply. This is called multiplicity. The number of the exponent is called multiplicity. So the multiplicity of x minus 1 factor is 2. The multiplicity of x plus 2 factor is 1. And that's really important when you think about multiplicity. In fact, let me show you this. You want to write this down. as you consider this highlighted portion of this in the book. When a factor of a function is raised to an odd power, the graph of the function crosses the x-axis at that place. Now, when a factor is raised to an even power, the graph is tangent to the x-axis at that place. So that's very important. When it's odd, it crosses, and when it's even, it's tangent. Okay? That's very important to understand. Now, let me go back to my graph. Remember, we got, let me zoom. We got x minus 1, and that's an even power. It said it's tangent at 1. See, at 1. Oops. Here is 1. You see how it touches? It don't cross. What that's telling you is that 1 is actually a factor twice. There's a multiplicity of 2 there because it touches. It bounces off. Or at least 2 because it's an even power. And notice how it crosses at negative 2. See, 1 and negative 2 are the solutions here. And since the power here is odd, it crosses, and the power here is even, so it touches. A tangent means it just touches at one place. That's all it means. Okay, so that's very important. If you can use a graphing calculator, a graphing function, which your laptop should have, that's very helpful. All right, let's keep going. Okay, so made a little mistake, so I'm coming back here and fix it. Now, if I'm writing a polynomial function with these parameters, the thing that you need to know, it has a leading coefficient of 1, and 2 and 1 plus I are zeros. What I wrote down right here is if you have 1 plus I, then automatically 1 minus I is a 0. And the reason for that is because of this property here, these two theorems that you need to copy down, that I'm probably not going to hold up long enough for you to copy them both down. But it's the complex conjugates and irrational conjugates, okay? So let's talk about what they really mean. All that simply means is if I give you a 0 with an I or a square root, then by default, automatically, the conjugate, which means change the sign in the middle, is also a 0. So I gave you this one, that means this one is a 0. And so what you do is you take each 0 and substitute it into the box there. And so that becomes x minus 2. You take this and put it in. I had to use brackets here because I already have parentheses there. It looks a little strange, but you actually take that whole thing and put it in the box, and that's what I did for both of those. All right. Now, as we start working the problem, we need to simplify. And so if I simplify this, it'll be x minus 2, or when I say simplify, I'm going to rearrange the order here. All right. And that'll be plus I. And that'll be x minus 1. That'll be minus I. And that is called the associative property. Now I'm going to hold off on watching this for a second. My first hour, I think I did it a little bit different first hour. And so you might want to really pay attention to this. I'm going to ignore this for a second and just focus on this. If I just look at this, I really have a difference of squares, or I have, whenever you multiply something that has the same thing but different signs in the middle, you see that x minus 1, I and I, but the only difference is this, the middle sign. The truth of the matter is when you multiply stuff like that, all you have to do is multiply the first two and the last two, because the two middle terms will subtract out. The two middle terms will combine to be 0. So if you don't understand what I just did or what I was just talking about, imagine this being x plus 3 times x minus 3. When you FOIL that, you'll get x squared minus 3x plus 9. What happens to those two? They cancel out. So that's what happened here. This is like your x and this is like your 3. The middle terms will cancel out. And so I need to simplify this first, which is different from what we did in the first hour, guys, so pay attention. I need to simplify this first all the way. This becomes x squared minus 2x plus 1 because negative I squared, if I go off to the side, negative I squared, remember I squared is negative 1, so that equals just plus 1 or positive 1. So that became positive 1. So ultimately, x minus 2 times x squared minus 2x plus 2. Now that I've gotten to this point, again, I'm trying to find a polynomial, so I have to take it back to something we did earlier in the year, and that is multiplying a binomial times a trinomial. So x times x squared is x cubed, x times negative 2x squared, and that's plus 2x when you distribute that x. Negative 2 times x squared is negative 2x squared, just combining like terms or putting it where it needs to be. And then negative 2 times negative 2x is negative 4x, and negative 2 times 2 is negative 4. Actually, that's a positive 4x, isn't it? Negative 2 times negative 2, that makes a positive 4. Okay, so that's x cubed minus 4x squared plus 6x minus 4 is your polynomial, which is what I was asking you to do, is find me a polynomial of the least degree that has real coefficients. Notice that all my coefficients are real numbers, so I couldn't leave it with the i's. I couldn't stop right there. All right, I don't know if I have enough time, but I'll try to do another example. Okay, your instructions really will say write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1. So they don't want a lot of radicals and stuff in your answer. Notice what they give you as your zeros, and based on that, one of those properties or theorems you should have wrote down. And I told you earlier, whenever you're given the zeros, all you do is substitute into this formula. So I'm going to do that. X minus 3 is this one. However, whenever I'm given a radical or an imaginary number, I have to also know that 2 minus the square root of 5 is also a 0. That's also, it goes with it. They don't tell you both, but you have to know that. That's something you have to know. So what does that mean? That means that x minus 2 plus the square root of 5 is a 0, and x minus, in parentheses, 2 minus the square root of 5 is a 0. Okay? Notice how I write these. It's very important. And also notice how I regroup them, because now this is going to become x minus 2 plus the square root of 5, and x minus 2 minus the square root of 5, which, just like the last problem, makes this to where I can actually just focus on these two, and the first two I can multiply together, and the last two, because I know the middle two terms, will subtract out. So let's do that. I'll get x minus 2 squared, if I use brackets here and parentheses, and then I will get minus the square root of 5 squared. So square that, square those two, it's minus because those two multiply, become a negative. So what does this actually simplify down to? Okay, well then it'll be x minus 3, and this is a FOIL, so that'll be x squared minus 4x plus 4 minus 5. When you put that in your calculator, that's actually the square root of 25, which is just 5. Or whenever you have a radical times itself, it equals 5. I went ahead and finished it up for the sake of time. And so one mistake was that I put the parenthesis close sign right here. It shouldn't have been there. It should have been right here. So from this line to this line, 4 minus 5 is negative 1. From here to here, I multiplied. See, we're using old skills. We always remember the stuff that we taught because it comes back. Multiply, and I get, combining like terms, I get this right here as my answer. And so this is the process. What you have to remember is those theorems that if I give you a square root or an I, you have to also know that the conjugate, which means just change the middle sign, or the first sign if it's only one term, is also a factor. You got questions? Let me know. Since I hope this makes, yes, I said that backwards.